Okay, section 1.4. It said number 45 is the problem that causing people problems. Part A said if f of x is ax plus b, show that f of x is also a linear. This is a constant times x plus a constant. That's like mx plus b. A number times x plus a number is linear. And we're supposed to take f of x, I'm going to write it twice here, ax plus b, and then put that inside of f of x, which is ax plus b, and show it's linear. So f of x, this is going to be used in place of the x of the other one, in place of the x of the other one. So we're going to put it in for the x, and we're going to get f of x. The composite of f is going to be a times ax plus b. That's what we're putting in place of the x, plus b, which will be a squared x plus ab plus b. Well, if a is just a number, a squared is just a number, so we've got something, basically a number times x. And then if b is just a number, a times b is a number, plus b, that would be just a number. So we have a b, we have a number times x plus a number, which is like a linear function. Okay, so it's a linear function. Then on this problem, they said, all right, if that's true, part B, g of x wants to come out to be 6x minus 8. Well, if we're going to do a function and a function and it comes out linear, function of itself, it probably was a linear like it said up here. So the slope of the result is 6, so that must be the a squared. So a squared is 6, which means a could be plus or minus the square root of 6. And there's probably a couple that, so there'll be two answers to this, but we'll go with it here for right now. And the AB plus B would have to be the negative 8. So all right, so moving down here. So what is the B? So g of x, we're saying is going to be ax plus b. We found that a could either be the plus square root of 6 or the negative square root of 6. We got to figure out the b. A times b plus b has got to be negative 8. So if we use the plus square root of it in here, plus square root of 6 times b plus b equals negative 8. Factor out a b, so this would be b times square root of 6 plus 1 equals negative 8. And then I would divide both sides by the square root of 6 plus 1. To get that to cancel, and I get b is that. And if a was negative square root of 6, it would be negative square root of 6 there. So g would be then a, I'll just do one of them here. G would have to be square root of 6 x plus negative 8 over square root of 6 plus 1. And to check, we'll actually put g inside itself. So I'm going to put all of this in place of the x in g. So I'm going to have square root of 6 times g of x, square root of 6x minus 8 over square root of 6 plus 1 plus negative 8 over square root of 6 plus 1. And hopefully this will turn out to be the 6x minus 8. So we'll take this times this, and we get square root of 6 times square root of 6x, which is 6x, so that part's good. And we take this times this, and we're going to get minus 8 square root of 6 over square root of 6 plus 1 plus 8 over negative 8 over square root of 6 plus 1. They have a common denominator, so I can add the numerators, and I get 6x and plus a negative 8 square root of 6 minus 8 over square root of 6 plus 1. I can factor out a negative 8 and negative 8, and I would have square root of 6 plus 1, because negative 8 times the square root of 6, negative 8 times the 1, and so this part would cancel, and I get 6x minus 8. These canceling to be 1 times 1, or just 8. So that worked. G of x, g square root of 6 times x, but we put g inside of g of x, plus that. So put this in place of this x to get this, and simplified it. And it would work with negative square root of 6 here, negative square root of 6 there, and negative square root of 6 there, and it would simplify the same way, and it would also work.